You know what your TBBS is capable of. But even power that is easy to control can be intimidating when you first try to use it. Fear not. While TBBS has power and flexibility to spare, with just a little knowledge and practice, you'll be well on your way to creating exactly the BBS you want.
Hi, I'm Phil Becker, creator of TBBS. We all remember what it was like to be that student driver and to feel that unique combination of terror and excitement. It didn't take long for driving that car to feel as natural as breathing, but on that first day you probably wonder how you would ever do it. That same feeling returns every time we start to use any powerful new technology. And while the concept of a BBS is very simple, to design the multi-user BBS you want and make it operate reliably, you're going to have to control some of the most complicated aspects of the computer art. Multi-user computing, modem communications, menu and human interface design, and protocol-based file transfers, just to name a few. But just as you don't have to know how to adjust your carburetor to drive your car, you shouldn't have to know about things like multitaskers and data protocol structures to build your multi-user BBS. Fortunately, you've bought TBBS, and I put all these things under the hood for you, so you can stay focused on designing your BBS instead of wrestling with the technology that makes it work. To help you through your student driver phase with TBBS, we're going to show you step by step how to put a 16-user TBBS together, create custom menu structures, and even install some of the option modules that you might want to use. And once you learn how to use TBBS, you'll find that it leverages your power to design bulletin boards the same way your automobile leverages your power to travel. Before we get started, let's take a brief look at what's inside your TBBS package. You should have received a complete price list and the latest ESOF newsletter possibilities, along with some other materials you can get to later. The multi-port serial card and cable will be used when we add more lines later. What you need first is your TBBS software. Inside your TBBS package, you'll find several items. Notice your registration card. You'll want to fill that out and send it in so you receive your free issues of the Possibilities newsletter, which will keep you up to date on what's happening with TBBS. It also contains many valuable tips on how to use your software. Even though both 3.5 and 5 1/4 inch discs are included for your convenience, be sure to notice that your 5 1/4 inch discs are your proof of ownership. So if you're using the 3.5 inch discs in your system, don't throw away the 5 1/4 inch discs, as you will need them later to receive credit for your upgrade. Along with the reference manual, you'll see the Understanding How It Works manual. We'll be referring to these manuals in the second part of this video, where we'll teach you how to customize your TBBS. Together with Alan Bryant, I'm going to show you how to install a 16-line TBBS system. We'll assume that you've already had the phone company install phone jacks for each of the 16 lines, or however many you actually plan to use. If we installed everything at once and made any mistakes, it would be very difficult to figure out what was wrong. So we're going to first install a single telephone line and modem using one of the internal serial ports on our computer. When we're sure that's working, we'll add serial ports and modems one at a time until we have all 16 lines installed and tested. This way we'll catch any problem early, so finding and fixing it is as easy as possible. So Alan, if you'll put the first disk in the A drive and type A:"install, we'll get started.
Sure. After the eSoft logo screen appears, press the spacebar to start the installation process. After you read the screen welcoming you to TBBS, go ahead and press the spacebar again. You will be asked whether this is a first-time installation of TBBS. This question exists because the same procedure is used to upgrade older TBBS installations as well as do new installations. We'll answer yes to this question since we're performing a first-time installation. Next, Install asks which floppy disk drive you're installing from. We'll answer A, but we could answer B if you were installing from the 3.5-inch discs on a dual floppy system. The installation program then asks which drive you wish to install TBBS on. We'll use the default C drive. Install then asks which directory on the selected drive you want TBBS placed in. Again, we'll use the default TBBS directory. Now that install knows where you want everything put, it asks which of the 3 sample systems we want. It also lets us peek at the top-level menu of each system to help us make our selection. The sample systems vary only in their appearance to the caller. They all have the same functionality. They demonstrate the wide range of appearance that TBBS can have. We'll select the 3rd system for this installation since it's the simplest version to modify if you're just starting out. Install then asks if you want a log of the installation. We'll answer yes, since a log can be useful if something goes wrong. When install confirms that it's generating a log, press the spacebar to begin the actual installation of your TBBS. During installation, you will be prompted when you need to change disks. Insert the requested disk and press Enter each time. After all of the files have been copied, Install says it's going to compile your menus. We'll get into more detail about what this means in the second part of this video. For now, press Enter and Install will run the SDL compiler and create your menus. When it's done, you'll see the output of the compiler, which should indicate no errors. Press any key to continue. The final step of installation is to assure that your AutoExec BAT file is set up to start your TBBS automatically and that your config.sys file has enough files and buffers to run the number of lines you want. On a first-time installation, you should let Install modify your DOS files. Backups are automatically made so that you can recover from any errors which occur during this process. The question of how many phone lines is used only to determine how many files equals are put in your config.sys. There is a formula on page 1-6 of your TBBS manual which you'll want to refer to if you add more lines in the future. The installation is now complete. Install gives you an opportunity to read the installation log. Lastly, Install gives you an opportunity to view the README doc file that was on your TBBS release disk. This file has last-minute updates or corrections to your TBBS manual. Now that TBBS is installed, it's time to connect your modem to the serial port and tell TBBS the type of modem you have and which port it's connected to.
Like most PCs, our computer has 2 serial ports built in. We'll use the COM1 port for our single-line installation. Make sure you use the proper connector. Serial cards can have either 9-pin or 25-pin male connectors. Check your PC's manual if you're unsure about which connector connects to which serial port. Connect the cable firmly to keep it from being loosened as you move things around. The other end of our serial cable connects to the back of the modem. Next, we attach the modem's power cable and turn it on. You should see 1 or more LEDs light up on the front panel. The last connection we need to make is the telephone line. Insert the modular cable in the jack on the modem labeled line. Most modems also have a jack that says phone. In many modems, these 2 jacks function differently, so it's important to check and make sure you've plugged the cable into the one labeled line. The other end of the modular cable plugs into the RJ11 telephone jack on the wall to complete the physical installation of our modem.
After you have connected the modem, use cedit, TBBS's configuration editor, to tell TBBS about this new modem and where it's connected. cedit is run from the DOS prompt with TBBS offline. Since we're installing a line, we pick COM ports from the menu bar. TBBS refers to its lines as ports, so we select port definitions. We plugged the modem into line 1, so that's the line we select. This is a 16-line version of TBBS, so you'll see 16 lines in this window. Other sizes will have a different number of lines in this window. The first step in defining a port is to tell TBBS what kind of modem we have. Ours is a Hayes Optima 144 modem, so we'll just type the first few letters of the brand name and press enter. Using the arrow keys, we can move up or down the list to highlight the desired modem and then press enter. A pop-up window appears with information about the modem we've selected. Read this information carefully before proceeding, then press escape to continue. Now that we've selected our modem, we need to tell TBBS about the serial port. Throughout cEdit and any of the TBBS editors, full context-sensitive help is available at any prompt by simply pressing F1. Don't forget that these online help screens are always available as you proceed with your installation. The first port setting is the base address. Since we've attached our modem to COM1, we type a 1, then press enter. When you pick COM1 or COM2, TBBS fills in the IRQ number for you automatically, and it does not need to be changed. We're using a modem, so we set hardwired to N for no. Your TBBS manual tells you about hardwired non-modem connections to TBBS. The next two settings, half duplex and only 7 bits, are used for special applications and are virtually always set to N for no. Press enter until you reach the last setting we're concerned with, the RTS-CTS flow control setting. When you select a modem, cEdit will change this setting automatically. Generally speaking, high-speed modems will have this set to Y for yes, while others will have it set to N for no. Just press enter to accept the automatic setting. The remainder of this screen is used to set up special access flag indications for modem speed and/or line number. We'll just accept the defaults and press F10 to save our changes. Press escape repeatedly until cEdit asks whether you wish to save your new configuration. Answer yes. cEdit asks where you want to save the TBBS configuration file. Press enter to accept the default.
Now we're ready to start up our TBBS and dial in from another computer to make sure it's all working okay. Alan, if you start TBBS, I'll get our terminal program running and dial in.
Sure, Phil. To start TBBS, type Run BBS at the DOS prompt while in the TBBS directory. Within a few seconds, you'll see the TBBS console screen indicating TBBS is up and running. The status for line 1 should show idle if the modem and serial port are connected and configured properly, and you've set up cEdit to match the configuration.
Now I'll dial our single-line system. As you can see, TBBS answered the phone and our connection started. I'll log on with the default information for the sysop or system operator, which is the ID SYSOP. TBBS recognizes this ID from our default installation, and we'll type in our default password, which is PASSWORD. This logs us into the system, and as you can see, the top-level menu looks the same as it did in our installation, so it looks like everything is working just fine. You'll want to change the sysop password, and we can do that online right now. If we press P from the main menu, TBBS will ask us to type in our current password. Again, we type PASSWORD. We now enter a new password, and TBBS will ask us to type it again because it wants to be certain that we have the right password. We've now changed the sysop password, and we're ready to go on with our installation. Be sure and pick a password that you'll remember, but which isn't likely to be guessed easily by others.
One very important thing to know is that newer high-speed modems place much more stress on a serial port. The heart of a serial port is a computer chip called a UART, and the UART used on most standard serial ports isn't capable of handling data speeds higher than 9600 BPS. A special UART called a 16550 is needed to handle high-speed modems. All multi-port serial cards supplied by eSoft come equipped with these UARTs already installed. But if you'll be operating TBBS with high-speed modems on a regular serial port, you'll need to replace the UART chip itself to prevent loss of data and errors on file transfers. If the UART chip is permanently mounted to the serial card or to your computer's motherboard, you may not be able to replace it. If that's the case, you'll need to purchase either a serial card that is equipped with 16550 UART chips or one that can have its chips changed. Page 1-55 of your TBBS manual explains more about this topic.
Now that we have our TBBS installed and running on one line, it's time to add more lines. However, we are now going to require TBBS to use more than the base 640K of memory. TBBS uses EMS memory, also called expanded memory, to break DOS's 640K barrier. So before we begin, let's test that our computer has EMS memory configured and that it is operational. To do this, we use the memory testing program EMS Test, which comes with TBBS. If this program reports any errors, then you must get your EMS memory configured and installed properly before you can proceed. EMS Test also reports the speed of memory switching, so you can compare varying EMS driver programs for efficiency if you desire. Once we've verified our EMS memory, our next step is to install one 8-port serial card and 7 more modems to make a total of an 8-line system. The first multi-port board is easier to install because it comes from the factory already set up the way we need it. But let's verify that none of the switches or jumpers have been disturbed by comparing their settings to those given on page 1-30 of the TBBS manual. The first set of switches controls the address of the status port. Compare the switches to those shown in the manual and then set as indicated. After the status port switches, there is a set of switches to control the base address of each of the 8 ports on the board. They are in order from port 1 through port 8. Again, verify that these switches are set as indicated in the manual. The next configuration item is the IRQ and board ID jumpers J1 through J10. There is always a jumper on each of these connecting the center pin to either the top or the bottom pin. Verify that these jumpers are set as indicated in the TBBS manual. The IRQ selection jumpers will generally only have one jumper in place, but the board is shipped with 2 because some unusual setups may require it. So we remove the jumper at J89, which we do not need. The final configuration jumpers are on the daisy chain connectors P2 and P3. Until we add another multi-port board, these 2 connectors must have a jumper across their center 2 pins. Now that the multi-port board is configured properly, we'll install it in our computer. Be sure the card is seated firmly in the socket. And then connect the large end of the cable to the multi-port board's socket. In some cases, you may need to press the sides of the opening apart gently to make it wide enough. It is critical that this connector seat well, and its metal cover must go through the PC's slot openings and touch the connector on the board. Since the multi-port board is using the same IRQ as COM2, we must disable that COM port on our computer's motherboard. On this computer, that is done using the setup utility. On some machines, it may be done by removing a jumper or changing switches on the motherboard. Consult your computer's manual for how to disable the onboard serial port. If the serial port is on a plug-in card, of course, you can always just remove that card if the port cannot be disabled. It is critical that the port be disabled or removed, or the multi-port board will not function reliably. The final step is to plug the multi-port board cables into the modems and then define each additional line in cedit. We'll first change the base address and IRQ of the line we have been using, and then we'll define the 7 additional lines and set their base addresses and IRQs as shown in the table on page 1-31 of the manual. Once we have done this, we should have a working 8-line TBBS system. As I dial in from the terminal program to test each line, from the TBBS console, Alan will be able to see each line log on.
From the TBBS console, we can watch each line as Phil logs on and verifies its operation. Looks like all of our lines are running fine, so we'll get 8 more lines running to make our 16-line system. Adding more lines to our working TBBS is simple. All we need to do is add another multi-port board, 8 more modems, and configure the additions in cEdit. We'll start by adding another multi-port board. Before we put it in the machine, we'll configure the jumpers and switches according to the TBBS manual, page 1-32. Follow each step in the manual in order to make sure the card is set up correctly. Insert the board in a slot adjacent to the first board. Since both multi-port boards operate on a single interrupt, we need to connect them using a daisy chain cable. With both boards in the machine, remove the P2 jumper from each board, then attach the daisy chain cable where the jumpers were removed. Finally, attach the serial cable to the board, then connect each modem. After you've connected another 8 modems, again use cEdit to configure the additional lines using the instructions on page 1-32 of the TBBS manual. This is done in the same manner as we showed you earlier when we configured 8 lines. Again, select your modems from the menu. The base addresses and IRQ numbers are provided on page 1-33 of your manual.
Again, I'll dial in and test our last 8 lines, and from the TBBS console, Alan will be able to see them log on.
Looks like we have an operational 16-line TBBS system. If you have problems at any point during installation, you should first check all connections. Make sure the multi-port cards are installed in their slots in the PC firmly. Make sure the cable fits completely in the multi-port board's connector on the back of the PC. Make sure the cable is inserted firmly into the back of each modem. If the system still seems to have trouble, remove the multi-port boards and check the switches and jumpers against the settings shown in the TBBS manual to make sure you haven't made any mistakes in configuration. Some of these dip switches may have been bumped during board installation.
You've seen how to install TBBS and add modems and lines to create a working 16-line system using our sample configuration. Now it's time to tap the power of TBBS and do what you really want. Build your own custom multi-user system. To build a TBBS, you first have to understand how the elements relate to one another. When you use it, you think of TBBS as a single entity, but in reality it is composed of several parts. The overall structure and control of TBBS is established by menu templates, and these templates provide a control at a very fine level so that you can customize nearly 100% of your system's operation and appearance. The overall TBBS configuration, such as how many lines and what types of modems are defined, is contained in a file called config.ctl. Config.ctl is edited using the cEdit program as you saw us doing earlier. Together, config.ctl and your menus determine what your TBBS system looks like and what it does. TBBS defines one specific menu name that must always be present, menu 0000. A TBBS system may have many other menus in addition to 0000, but it must always have this menu. So we will use this menu and medit, the TBBS menu editor, to examine the internal structure of menus.
To see how a menu will look to a user, we use the medit view command. The view command displays the text elements of each active menu entry exactly as TBBS will do when the user accesses this menu online. The Set Level option allows you to configure the view command to simulate different callers' user log settings for privilege, flags, ANSI, and graphics. This allows you to see how each menu will look to each different class of caller your TBBS will have. For example, let's look at this same menu for an ANSI caller. Notice that although we are still showing the same menu, its appearance is quite different. This is because the view command is selecting the text from only the entries which will be active for each of the 2 types of callers. Now that we've seen menu 0000 from the user's perspective, let's look at how we can use medit to change its appearance or function. To do so, select Display and then List.
Each individual menu is composed of menu entries. A menu may also have an optional title. MEdit displays each menu one entry at a time, allowing us to look at the 3 sections of each menu entry. The first section is the text block. Any text contained here will be displayed if the menu entry is active. The odd-looking characters that you see, brackets, numbers, semicolons, are ANSI codes to set colors. These codes are described at the end of Chapter 2 in your manual. Large text blocks may be placed in an external file and included in a menu entry by placing that file's name in curly brackets. The second section of the menu entry determines whether or not the entry is active to a particular user or group of users. TBBS uses 2 individual systems, privilege level and access flags, which work together to provide you a high degree of control over your system and which of its functions any particular user can access. A menu entry is active if the user has a privilege level greater than or equal to the specified privilege. If any access flags are set to X or dot, the user must also have the corresponding flag set the same way in their user log to make this menu entry active for them. A privilege level of 0 and all access flags set to a dash will result in the menu entry being available to every caller. If a menu entry is not active, TBBS treats it as though it doesn't exist for that particular user.
The fact that each menu entry may be authorized independently is the secret to many advanced special effects you can do with TBBS. Several of these are discussed in the Techniques chapter of your TBBS manual.
The final section of a menu entry determines how a user will select this entry and what the entry will do if it is selected. The key equals portion determines which key the user must press to activate this entry. The type equals selects which of the internal TBBS functions will be executed when this entry is selected. These functions may be either menu flow commands directing TBBS to switch to another menu or return to a previous one, or they may be commands to read messages, download files, etc. Finally, the optional data field specifies any extra information the command might need, such as disk directories or configuration switches.
MEdit is useful primarily to view menus and make small changes. As you will learn in a minute, there is a better way to build your system's menus. But let's see how menus can be changed with MEdit first. To delete an entry that we don't want, position MEdit to that entry and press the delete key. Press Y to confirm the deletion. To change the text of an entry, press the F2 key and position the cursor to the text block. Change the text, then press Escape to exit text editing. Move the cursor to the key equals field and enter the new activation key we want. Press Escape again and answer Yes to save our changed menu. Now, if we ran TBBS, the menu would function in its changed state. That's all there is to altering the operation of your TBBS. Remember, menu entries define what your TBBS looks like and how it operates.
While MEdit is very simple to use, using it to create a system of any size is extremely tedious. Therefore, TBBS provides the System Definition Language, or SDL, compiler. SDL allows you to write your menus using any text editor and then compile them into the menu control files. This gives you the convenience of using all the features of your favorite text editor, such as block moves, copy, insert, delete, when you are building menus.
A further advantage of SDL is that you can maintain the source of several menus in a single SDL file and add commentary to remind you why you did certain things the way you did. In addition, SDL provides a sophisticated macro system which you can use to ease tedious and repetitive menu generation tasks. Although SDL allows you to write menus in text, the menu entries still have the same 3-part structure they do in MEdit. To see this, let's examine the SDL source for the same menu 0000 we were just looking at in MEdit. As we look through the SDL source code, you can see how the menu entries in SDL relate to the menu entries in MEdit. Each entry begins with the keyword entry. The text block begins on the next line and continues to the first keyword, such as priv equals or type equals. Notice how some of the SDL source code contains macros. In this menu, macros are used to make coding our ANSI sequences easier to deal with. SDL macros are defined at the beginning of the SDL source file. A macro can then be called out by using an @ sign followed by the macro name. Using macros makes many repetitive tasks, such as setting colors and creating common menu structures, a lot less time-consuming. To delete an entry definition, simply use the text editor. Changing a menu entry in SDL is equally simple. Just type over or replace the text you want to change. Again, we'll make the same changes we did earlier using mEdit. Once our SDL changes are complete, save the file to disk. Then, at the DOS prompt, we run the SDL compiler to generate our new menus. The compiler shows status information as it's compiling the menus and will also report any errors found in your source file. As you can see, the compilation is done and was successful. More details on using SDL are given in Chapter 7 of your TBBS manual. Finally, we'll run TBBS, log on, and take a look at our menu. You can see that the results are the same as they were when we used mEdit.
Most TBBS menu functions are simple and easy to understand because they involve only the menu template entry and possibly an external display file. But there are 3 functional areas which are a bit more involved. The first of these is message areas. For a message area to be used in TBBS, it must first be defined in cedit. This definition establishes the message board's name, its type, standard email or topic, and whether the private messages and enclosed files are allowed. Once a message board is defined, then it is used by simply adding menu entries that refer to it. Menu type commands 6, 7, 8, 9, and 24 are used to read, write, scan, and delete message boards, and to select multiple message boards for combined access in a single command.
The important thing to remember here is that you must define a message board in cedit before you can make menu commands reference it. And when you enter the message board name in the optional data field of a menu entry, you must make all upper and lowercase letters match the name you defined in cedit.
Perhaps the most difficult area of TBBS construction to understand is file upload and download areas. The basic concepts are quite simple, but TBBS provides hundreds of variations so you can have exactly what you want. TBBS has methods which allow file descriptions, access restrictions, grouping, searching by keyword, date, or file name, and control over very large multiple file areas. The simplest method is raw uploads and downloads. These use the type 29 and 34 commands and point directly at a DOS directory. Only the menu entry is involved in making this type of file area.
The next type of file area is called a pseudo-directory file area. These use the type 46, 47, 48, and 49 commands for upload, download, and directory maintenance. The menu entry will point to a text file called a dir file, which is the pseudo-directory. The dir file is a list of files for download, and its structure contains a tremendous amount of flexibility to accomplish a wide variety of missions. Let's examine an entry in the dir file in detail so we can learn how they're created. The format of the dir file is explained in Chapter 4 of your TBBS manual, and it may be helpful to have page 4-18 available to follow along as we look at this file. The first part of a dir file entry is the drive, path, and file name of the file as it exists on disk. If no drive or path are specified, it is assumed to be in the same directory as the dir file which references it. The second part is the pseudoname. This is the name by which the user will know the file. There are 2 names, so you can have the file on disk under one name and show the user a different name. This is especially useful for non-DOS files. Following the pseudonym is a description of the file, which can be up to 45 characters long. Extended description lines may be added to form a description of any length. You'll notice that our next entry has an additional field between the pseudonym and the description. This field consists of a user ID enclosed in single quotes. If this field is present, it indicates that the user is the owner of this file. If you select private download mode and reference this directory, the user will see only those entries which are his. In addition, all files which users upload are marked with this owner field so you can determine who uploaded them to your system. On the third entry in our dir file, you will notice that there is a file size and a date listed between the DOS file name and the sudo file name. Normally, TBBS will verify the existence and time and date of every file in a sudo directory. This process makes it so that when you change the file on disk, the directory listing will change with it, and when you delete a file, TBBS will know automatically to delete the corresponding dir entry. However, on very large file areas or CD-ROMs or other slow devices, looking up the date and time of every file every time it is listed can be very slow. So TBBS allows you to put the date and time here to avoid that problem, dramatically speeding up directory listings in these cases.
The final step in creating very large file upload and download areas is the Type 4 file area menu command. In the Type 4 command, the optional data references a FAR file, which is a list of dir files and descriptions which the Type 4 command accesses as a group. Page 4-27 in your manual describes the format of a FAR file. On the Type 4 command, the menu points to the FAR file, which in turn points to a group of dir files, which in turn point to the true files on disk. This combination of capabilities allows TBBS to solve more upload and download tasks than any other BBS software available.
The third function of TBBS that requires more than just the menu entry is questionnaires. Questionnaires allow you to ask questions in a survey fashion or record votes from users. TBBS also allows you to change many of the authorization settings as a result of the answers to questions. This is a secret of many of the advanced special effects you can do with TBBS menus. In your sample system, there is a new user questionnaire which we'll show you as an example to explain how this feature works. TBBS questionnaires are written with an ASCII text editor in a simple specification language called QAL. The capabilities of this questionnaire language are discussed in Chapter 8 of your TBBS manual. After you've written your questionnaire, the QAL compiler accepts the source questionnaire as input and then generates a binary file with an extension of QAF. In your menu entry, the type32 command points to this binary file and executes your questionnaire. The type33 command points at a QAF file which accumulates voting totals to display those totals along with the questions.
Now you understand the fundamentals of how the TBBS template system is used to design a custom bulletin board. Because TBBS is so flexible, it is usually helpful to begin by outlining your goals, sketching a menu flow, and being certain that you understand your mission before you begin. If you organize your approach, you'll find that TBBS allows you to create custom systems far beyond those you thought possible. Once your TBBS is designed, maintenance consists primarily of authorizing new users and maintaining the message base. The ULEdit processor is used to change authorizations and add new users. It has an internal template capability which can allow you to automatically authorize classes of users quite easily. Chapter 11 of the TBBS manual explains ULEdit in detail.
MFSqueeze is used to maintain your message areas. Your sample system sets up MFSqueeze to run automatically as an external event to keep the number of messages in your system at a set size. You can also use MFSqueeze to renumber the message base or to individually look at the message base offline. MFSqueeze is explained in detail in Chapter 10.
MFSqueeze and ULEdit run offline, meaning your TBBS system must be taken down for their use. However, often in a busy system, you may need to authorize users or copy files around or do other maintenance without interrupting service to your users. The SysOp option module, SysOM, is available as an add-on for your TBBS to allow this type of maintenance. eSoft also has available several additional option modules to expand your system. These option modules allow you to add advanced capabilities easily so your TBBS can grow to meet your expanding needs. One of the most important of these option modules is TBBS, the database system, which actually provides an X-based language database compiler and an integrated runtime so you can compile D-based programs and make them menu entries in your TBBS system for your online use. Offline reader support for the popular QWK format is available via the QSO option module, while FidoNet support for NetMail is available through the TIMS Integrated Mail System option module.
Many connectivity problems can be easily solved using the interchange module, which allows users on one line to access the modem on another line, to dial out, or to connect to adjacent machines from a TBBS menu option. It also can be programmed to automatically dial other systems on a timed basis and automatically transfer files while your BBS continues to run. Interchange even allows you to run door programs on slave machines and make them appear to be menu items on your TBBS. All of our option modules install easily by simply adding an option to your MLTBBS command line in your Run BBS batch file. Each option module eSoft sells then will bring into being a new menu type command which allows access to the option module's extended features as though they had always been a part of your TBBS.
eSoft is constantly adding option modules to enhance the power of your TBBS system. So even after you have tapped the power of TBBS itself, the possibilities remain unlimited. If you have any problems with your TBBS, please refer to Chapter 12 of your manual, which gives extensive troubleshooting information. Chapter 12 also gives you information on how to access our free technical support. You can obtain support 24 hours a day on our Support BBS or by calling our technical support line during normal business hours. If you take the time to plan your BBS and learn the things we've discussed in this tape, you'll find that TBBS gives you the power and flexibility to create nearly any online system you might imagine.